Okay, so here we go, number 14. So it says Roy is pushing a merry-go-round. The merry-go-round, which is 4.5 meters across, a big merry-go-round, has a mass of 240 kilograms, and it can be treated as a disc. Roy pushes the outside edge with a force of 300 newtons for 5 seconds. So let's make ourselves a little drawing. Here's the merry-go-round. The problem tells us that the radius is 4.5 meters. The mass of this thing is 240 kilograms. It tells us it can be treated as a disk, so right away I know my I is 1/2 mr squared, just from the rotational inertia sheet. Everybody cool with where I got that? Okay. Roy pushes the outside edge with a force of 300 newtons. So here's our force from Roy, 300 newtons. It tells us he does this for 5 seconds. Roy's cat Fluffy is sitting 1.2 meters from the center of the ride. So here's Fluffy. I apologize, I realized this morning that I have 2 problems with a cat on a merry-go-round, which is really just kind of lazy. So I'll do better. I can do better. All right, so here's the cat. Give me 1 second, let me identify this 1.2 meters. I have 2 R's. So I'm going to call this the radius for the cat. So R will be the radius of the merry-go-round, RC will be the radius for the cat. That's not the radius of the cat, that would be a very fat cat. It's the radius of the circle that the cat is orbiting in. Follow? Nobody thought my fat cat joke was funny? I'm a little mad at you guys. Jacob.
Would it be worded better because it says the merry-go-round is 4.5 meters
across?
Like,
that's, no, you're right. Yeah, I'm wrong. The radius is not 4.5 meters. The radius is half of 4.5 meters, which explains why I was worried about the merry-go-round being so big. So the radius of the merry-go-round should, fiddle-faddle. Man, what is going on with me today? Not that I'm always like, all right, so half of 4.5 is 2.25 meters, yes?
Yeah.
I like that better. Thank you. All right, is everybody good? I apologize for my ineptitude. We're good? All right, so the question wants to know what velocity Fluffy is going to reach. So first of all, I'm trying to remember. There was a big mistake that I remember a lot of people made on the test for this chapter last year. And it was something, because I wasn't doing target checks, I didn't catch early on. You can't use Newton's second law here. Okay? You can't do force divided by mass. Okay? Do you guys understand why? Somebody want to try to tell me? Why can't I do 300 newtons of force on the merry-go-round divided by its mass at 240 kilograms to find the acceleration?
It's not linear motion.
Good, it's not linear motion. If the whole merry-go-round was moving under the action of that force, you could do that. But that's not what's happening. Okay? So this chapter, you're almost never going to use F equals ma. Okay? Because everything is rotational as opposed to linear. All right, so is everybody good with my given information? All right, so I want to find I. Which radius should I use? Should I use the radius for the cat or the radius of the merry-go-round? The merry-go-round, right? Because the merry-go-round is the thing that has rotational inertia, right? Because that's the thing that's rotating. So when I find the rotational inertia for the merry-go-round, I'm going to do 1/2 the mass of the merry-go-round times the radius of the merry-go-round, which, thank you again, Jacob, is 2.25. So when you figure that out, it gives you a number, which is 120 times 2.25. Don't forget to square it. 607.5 kilogram meters squared. All right, so there's our I. What else can we find, you guys? What other important information do I have in my FD equals I alpha thing? Yeah, I know my force and my distance, don't I? I know the force providing the torque is the 300 newtons. What's the length of my lever arm, you guys? 2.25, right? Because the force is exerted at the outside edge, right? So my lever arm is also 2.25. So it is possible for your lever arm to equal your radius, but not necessary. Okay, sometimes they're equal, sometimes they're not. Okay? So I think I can use this information here to find my net torque, FD, right? So 300 times 2 1/4 is 675. Is that right? Yes. Final answer. Okay. Everybody good? All right. What else, you guys? Where should we go from here? Let's see. We know our net torque. We know our I. What should we find now, you guys? Yeah, the angular acceleration, right? So our angular acceleration should be torque over I, right? Do you guys understand that this equation replaces Newton's second law, right? Instead of A equals force over mass, it's A equals torque over inertia. All right, so you get 675 over 607.5. Gives you a number that I, once again, don't know. 1.1 repeating. Is that what you guys got? Radians per second squared. Good? All right, so now I know how quickly the merry-go-round is accelerating angularly. I think I added an extra syllable in there. All right. What are we trying to find? The velocity final of the cat. So, good. So the cat and the merry-go-round have all the same angular quantities, right? But different radii. Okay? So, where do you want to go from here? There's a bunch of ways we could do this. Use the jumper right now and find the linear acceleration. I like that idea too. Let's find the acceleration of the cat. That's going to be the angular acceleration of the cat times the radius of the cat, right? So, this is just getting taller and skinnier instead of, oh, see, this stupid smart board.
It's not very smart.
No, well, I just wish there was like a happy medium, right? Like, I like that I can do this on this screen, but then I have all this garbage up here that I'm not using. I'm sorry, none of you care. Quit your bitching, hacker. All right. All right, so here we go. So the acceleration of the cat is his angular acceleration, which is 1.1 radians per second squared. His radius is 1.2 meters. I know, I just recorded myself swearing. You can get me fired now if you want. So what does that give you? I apologize, no offense intended. That doesn't really cover my back, but... All right, there we go. Everybody good? All right, so that's the acceleration of the cat, and now you just do VF equals VI plus AT, right? So VF equals VI plus AT. Initial velocity of the cat was 0. Acceleration is 1.3 repeating. Time was 5 seconds. So 5 times 1 1/3 is 6.6 repeating. Thank you. Meters per secundo. Cool? Any questiones? Going once? Twice? Sold. All right, very good, very good, very good. All right, so for 13.